Slides 233 and 234. Bulk check sheets, or bulk ITRs as they are known. Bulk check sheets are used for multiple instances of the same tag type that can be checked by the same inspectors during the same visit. Examples are low voltage cables for electrical, instrument or telecoms, junction boxes for electrical, instrument or telecoms, instruments of the same tag type in the same room or enclosure. Other tag types could be motors or pumps, potentially in the same area. In Xenitor, the same approach is followed so that power users can quickly set up bulk AITRs or bulk BITRs for logical groupings of equipment, where both parties have agreed bulk ITRs can be applied. The benefit is to the project by saving management time, but not compromising quality or integrity. Slides 235 and 236. Test packs, loops and circuits. Electrical circuit, instrument loops and piping test packs have a special type of one-to-many check sheet that enable verification checks to be performed on multiple tagged items of the same tag types. In the case of piping test packs and electrical circuit, or of the instrument tags that form a loop. Test packs, loops and circuits are TLCs. Obtain agreement first between the operator and the contractor on the size and formation of logical groupings of equipment. Creating electrical circuit ITRs, instrument loop ITRs and piping test pack ITRs in Xenitor is a very similar process to creating bulk ITRs. Slide 238. Rules for successful use of test pack, loop, circuit and bulk check sheets, also known as TLCB ITRs. Use the relationship between the competency, trust and scale of deployment model. Rules for the successful use of test pack, loop, circuit and bulk check sheets, the TLCB ITRs. Apply the trust, competency, scale of deployment model. Ensure the operator and contractor work closely together to agree the size and composition of the logical groupings to be applied to bulks, circuits, loops and test packs. Keep deployment of bulks, circuits, loops and test packs proportional to the level of trust. The trust, competency, scale of deployment model. Establish rules that determine a logical grouping. Tagged items, for example, that have in common the tag type, the location, its room or module or building. Ensure that all verification checks can be completed by the same engineers or technicians during the same visit. As an example of recent abuses of the use of bulk check sheets, we have attempting to put all instruments of all types onto bulk check sheets, and also attempting to put every motor onto the same bulk check sheet. These are the situations we are trying to avoid. The check sheet types to be used are for the completion of activities shown in the completions pyramid, namely for factory acceptance testing, for mechanical completion, pre-commissioning, function testing or static commissioning as it's also known, then dynamic commissioning, followed by startup and performance testing. In Xenitor, there are the following check sheet types. Single check sheets, one-to-one relationship of one check sheet to one tagged item. Bulk check sheets, one-to-many relationship of one check sheet to many tagged items. Electrical circuits, one-to-many relationship of one check sheet to many electrical tags within the circuit. Instrument loop, a one-to-many relationship of instrument tags within the loop. Piping test packs, one-to-many relationship of one check sheet to many piping tags within the test pack. For guidance on check sheet types, definitions of the stages to final acceptance and general guidance, refer to the embedded file. The list of tag types will come from the engineering deliverables, including, but not limited to, the equipment list, the piping line list, the cable schedule, the instrument index and the instrument loop list. An overage of check sheets to tag types is a good place to be, because then the project has more than are needed and can remove those that are surplus to requirements. In the situation where the number of tag types is greater than the number of check sheets, two things will need to occur. First, logically rationalize the tag types where possible so that several tag types can be adequately covered by a single check sheet. This situation often arises within instrumentation tags. Many instrumentation tag types, such as transmitters, transducers, transponders, flow, temperature, pressure measurement devices, can legitimately be covered by a single check sheet for installation and another check sheet for calibration. If a number of tag types is greater than the number of check sheets, create the new check sheets to fill the gaps. A. With special items, get the vendor to prepare an initial draft of scope, then customize a check sheet template. B. Discipline engineers in the commissioning team should prepare the scope, then customize an existing check sheet template. C. Choose an existing template closest in scope to the missing check sheet, then modify and save as new template. In parallel with choosing the check sheet types required for the project and the gap analysis is completing the tag type matrix, or TTM as it's also known. The TTM is an important summary level document defining the choice of check sheets to be used to complete each tag type. For many experienced contractors, the TTM is formalized in their work practices and routines. It is simply the way they do things. And supervisors know that from project to project, certain check sheets are used to complete certain tag types. On a new project, for example, the commissioning manager will either need to create the TTM from scratch if one does not exist, or use a TTM from a previous project. When the TTM has been set up, importing it to Xenotor is easy. Use the spreadsheet template supplied within Launch to externally set up your project's TTM. Then import the template to Xenotor. Exporting the project's TTM is handled by Reports Plus. Look at the format of the TTM you get in Reports Plus. This is shown on slide 252.